Good morning, dear participants. Today we are moving to the fourth day of our meeting, and the resource person is from CoreEl Technologies. We will introduce him later, and I hope Mr. Shashi has joined. I think no, Shashi sir. Yeah, sir. Yeah, you want to make that adjustments? Please do it now, and we will move to the session after introducing you.
Sure, sir. I think everything looks good. I'm good at my end.
Okay. So, shall we start now?
Sure, sir. Yeah, I mean,
Yeah, just a minute. Just a minute. Good morning, dear friends and the experts. Today we are starting the session with the CoreEl Technologies. The expert is Mr. Shashi Kumar, JK. He is an application engineer at CoreEl Technologies, Bangalore. He works with faculty and researchers to enable effective use of the tools like MATLAB, Simulink, and hardwares. Development tools such as Xilinx products is in the curriculum and research. He will help for the developing the curriculums using this Xilinx and Xilinx products. He is specialized in embedded system design, IoT, wireless system, data analytics, machine learning, deep learning workflows. We are very much lucky to get such a person who is really doing the applications, and he is going to share his experience with us. Is a very nice platform like this ATAL FDP. So we thank to ATAL and that CoreEl Technologies. They come for the CoreEl Technology come forward to depute such a nice person. So I thank Boban of CoreEl Technology who has introduced Shashi to me. So now we have to hear from Shashi, and we have to interact with him and get more thing, and how we can collaborate with the R&D and the others using this. And he's going to take a nice topic with the AI and AR VR platform. Okay, so nowadays AI is much more important everywhere. They are starting the interdisciplinary courses like AI and data sciences. So it's very nice that how we are going to link with this these problems. Okay, so normally this AR and VR widely they are using for the wisdom applications. Now only that is we are much more using. We are trying to incorporate with the engineering things, and even our topic is also with the robotics. So this is very much important session, I hope, and this section will create a good impact on our FDP. It's over to Shashi. Thank you.
Thank you, sir. Thanks for the warm welcome, and it's my privilege to be addressing all the participants here. And so yeah, so let's get started. Let me start by sharing the screen. Is my screen visible?
Yes, Shashi. It's very visible.
Yeah. All right. Bhavan, are you there?
Yes, I'm there, Shashi. Am I audible?
Yes, Bhavan, you're audible. So,
Glenn sir, good morning. Yeah,
yeah, please go ahead.
Good morning.
good
Good
morning to
morning.
all the participants. Yeah. My name is Boban Ignatius. I'm the state in charge for Kerala for CoreEl Technologies. I'll be just taking you through some details about CoreEl Technologies before Shashi takes up the details about the presentation. First of all, I would like to thank Dr. Glenn Devdas as well as the entire team of Vimal Jyoti College of Engineering for providing us this opportunity to present during this 5 days ATAL sponsored FDP on virtual and augmented reality for robotics. Uh, I would like to introduce our company first. We are a company based out of Bangalore, CoreEl Technologies. We were established in the year 1999, and we were a part of the Crompton Greaves Group before that. Earlier, we were called a CG CoreEl company, and now since 1999 we are known as CoreEl Technologies India Private Limited. We are a customer application specific product and solutions company and a leading developer of advanced electronic system level products and solutions to three primary markets. We cater to aerospace and defense, we cater to digital video solutions, and also to universities and institutions of higher learning. Uh, Next slide. Can you go to Shashi? Next slide. Yeah. So our major products are into radars, electronic warfare, sonars, missiles. We're also into live broadcast products and next gen operation rooms and intelligence gathering platforms. Next. Uh, this is one proud moment for CoreEl Technologies, wherein the Ashwini radar was developed by LRDE and it was on display at the Republic Day Parade of 2018. So, in this radar, the digital beam forming unit was developed by CoreEl Technologies. So that was a proud moment for us when this was on display at 2018. Uh, we are associated with many companies of repute across the globe. In terms of the electronic design automation tools, we are associated with MathWorks, Mentor Graphics, which is a Siemens company. We're also associated with Siemens for their CAD, CAM, PLM solutions and establishing centers of excellences across the country. We have already established few centers of excellences across NITs and IITs across India, including NIT Kurukshetra, IIT Goa, IIT Guwahati, and IIT Jodhpur. We are associated with 3D printing in terms of MakerBoard. In terms of university solutions, our team is from the university. Our team is called the universities program team. We are associated with companies like ANSYS, Siemens, as I already told you, MathWorks, Xilinx. We are the sole partners for Xilinx university program across India and Asia Pacific, and Mentor Graphics as well. Next slide. This is the details about our School of Embedded System Design called Sandeepani. It's a training division of CoreEl Technologies. We are the authorized training partners for Xilinx in India and Sri Lanka. We started as a VNSI training center and now we are known as Embedded System Design Center. We have trained over 5,000 plus professionals from various industries and our customers include startups, independent design houses, defense aerospace companies, and also universities and institutions of learning. We have hundreds of students who come to Sandeepni School of Embedded System Design every year to get additional certifications so that they can join core companies in the area of VLSI and embedded systems. Thank you so much, everyone. I now Shashi will take it over henceforth. Thank you so much.
Thanks, Pavan. Thanks for the introduction. So let's get started with the presentation. Right. So today it's about two segments. What I'll be talking about, and I've also created a drive folder where I can share you all the codes which I'll be demonstrating. Right. So I'll be using MATLAB as a platform for demonstration. So anybody who's here who's having MathWorks account, right? So you can create your online MathWorks account and you can access the drive files. They're just uploaded. So I'll put this link in a chat window, right? So you people can actually run the code alongside with me. It's a big ones because AR systems and all are quite extensive and a lot of things are involved. So I'll put this link in the chat window. So anybody is having any challenges in accessing these files, right? So please let me know. I've shared the link. So I'll be taking you all through these things, right? So first I'll be talking about AR augmented reality. So what it is and with the demo in MATLAB as to how we can develop such AR systems, right? So AR is not a new thing. We all know that. So it's quite old and it has gained light in the recent times because of its advancements. This dates back to in the 19 in the 80s, right? So that's where it dates back to. It's not a new technology. It's something old, but it has gained light now because of the technological advances, right? So now AR is something which we all interact in our daily lives, and we without actually knowing it, right? So we actually work with it, right? So I'll talk about how AI and AR can be related, right? So through exploratory analysis. And at the end, once I talk about both of these, so I'll talk about some challenges which we'll face while working with the AR systems or the AI systems, how they can be integrated and those things, right? So first I'll cover the AR aspect. Right? So, what is AR actually? Right. So can anybody, can you all post it in the chat window? How many of you have uh, played the Pokemon Go game? If you have played the game, please type in yes in the chat window. If not, you can type in no. So if you have, then you have already experienced AR firsthand, right? So what it does is it projects a Pokemon character on the screen and then you're looking at the camera of it, right? So I think this video will okay. So I can see some yes as well. So that is great. So that means that you have actually looked at, I mean, you have experienced AR at the first hand reality, right? So the basic idea here is of the augmented reality is to superimpose graphics, right? So we have our real time environment, which we have. Right, and we superimpose graphics. It can be audio or other sensory enhancements where we can visually perceive through alongside with our environment, right? So a new AR related movie, if anybody is keen on that. So I mean, I'm sure most of you all would be knowing Tom and Jerry, right? So now there is a new movie in Amazon Prime, which is completely related to our augmented reality type of a thing, right? So let's see some VR in real life, some examples as to what can be done. So there are a lot of advancements in terms of the real life implementation. So we have a VR class. So the young students have been given such a flexibility to use VRs in their education, and they can actually visually see, let's say, biologic. If you take biology, right, so all the complete human anatomy and can be visualized using these things, right? So AR is not a sci-fi future which we had thought, but it's today's reality, right? So with the COVID-19 pandemic, AR applications have become actually more prominent into our day-to-day lives. And so now that the travel restrictions and social distancing guidelines are there, so it's very difficult for us to get experts on the ground in front of the systems which require specialized knowledge, right? So how do we do that? So we look at augmenting reality, right? So let's take a small a snapshot of what are the different potential applications which you can look at, right? So this is from autonomous driving systems, which is used for navigation. This is 3D maps, AR maps, which Google and Facebook, they are also working on it, right? So you can develop smart applications. This is Pokemon Go. You would, if you would have played this, right? So this gives you an first-hand experience of AR as a whole, right? So a lot of potential applications are there. So organizations are increasingly exploring AR as a way to connect with the frontline workers, whether it's in a manufacturing facility or a hospital, right? So a lot of potential applications. So there is a statistics which I saw for the potential market in the AR domain. So it's actually going to reach up to around 200 billion by let's say 2023, 2024. Right? So it has all the visual systems, all the way we interact with the electronics, right? So it's going to change. So many of the companies are working with it. So let's see some live examples and live testimonies with where some companies are already working with AR and developing some applications for the market, right? So this is from InterSense. So what they have done is, so they've developed this motion tracking system. So this can be used for flight trackers. So this is for cockpit helmet tracking and system. So this can also be used for wide variety of applications. So they have used it for motion tracking and then see how a human can augment into our virtual reality. Right. So this is an again one more example from Airbus. So what Airbus has done is, so they have created such a 3D environment where they can augment, I mean, they can enter it, so they can manually give them some faults to the system and visually see in a 3D environment how that fault can grow in that aircraft, right? Also a faulty environment, so how do you repair and what are the things which has to be done, right? So this is already done by Airbus for their digital twin aircraft. So this actually enables the engineers to get a good grasp of what can be done, what is actually happening. If there is some fault which is diagnosed, right? So how should the system react, right? So, and take the necessary safety measures, right? So these are some applications where Airbus is already working on. Again, one more example from Volvo. So what they have done is, so this is an 3D environment where a participant here is actually working with the live excavator, right? So whatever operations he does here remotely, he's actually able to see it in an augmented one. So but then this is a hard human in the loop simulator. So manually he's actually operating some equipment in the real world, interacting with the real environment, but then he's not actually presently there, right? So he's somewhere remotely present, and then but then he's able to experience these what's actually happening and what's required, right? So these are some examples from the industry which where they've already been using AR for their development. So there are a lot of advances, a lot of companies are investing on AR, and it's already there, in fact, in the market. So we just have to we just have to get access to it, and shortly, hopefully in let's say a couple of years further, we'll be able to experience these in our hands, right? So what we'll be doing today is I'll take you through a simple example in MATLAB as to how can you develop such AR type of systems, right? So AR system, I mean, understanding the concept is all fine. So I mean, the concept is not that complex as it, but then it's all about how you develop, right? So I'm sure you might be thinking of game engines such as Unity, Unreal, right? So I mean that's a mix of virtual reality and augmented. So virtual reality is a separate aspect when it comes to AR. So virtual reality is something where you're specified to an environment, but then augmented is where we work in the real environment, right? So let's look at developing a small application here using MATLAB and so some toolboxes as to how we can work with it. Right. So here, what we are going to do is we are using a technique called segmentation to see superimpose objects on the other data or a scene, right? So we'll have a scene which is there at the background, which will superimpose into our live video stream, right? So MATLAB is such a tool where you can access all the hardware components, you can do real-time processing, right? So in this demo, I'll talk about how we can do that and what we have done. So segmentation, you must be aware of it, right? So segmentation is used to assess and separating certain regions, objects from different backgrounds and those things. All right. So there are a lot of different ways of implementing a segmentation. So in this demo, which I'll be demonstrating, right? So what we're going to do is I'm going to segment different snapshots of my webcam in real time, right? So let's take some of the steps in this demo file. Right, so I'm not going through the complete code here because this is barely a little bit lengthy code. So because a lot of things has to happen at the background, but then I'll give you an overview basis as to how you can do it. So probably, I mean, using the MATLAB Drive link, you can access the code yourself and you can try it yourselves as well. So if you have a possibility, if you're sitting in front of a laptop and you have MATLAB installed, you can actually try to run this code as well, right? So in this code, so first what I'm doing is I'm actually prompting for what background I want first, and once I do that, so then I you can see that there is a while loop. What the while loop does is it actually keeps on capturing the snapshots in real time and then keeps on looping to the complete code what we have, right? So this is the function for snapshot, and I use this function for segmenting the user from the background, and I superimpose. So these are all custom functions which I've written. I'll take you through the codes if anybody wants to explore and see what's actually done. At the algorithm, everything is already there, which is already being shared, right? So you just have to look at it and then how to take it. Right, so what I'll do now is I'll go to MATLAB and I'll show you how these codes work and what's actually happening. Right. So anybody has any questions in between, please feel free to put it in the chat window. I'll be answering those questions at the end or uh, when they're required. Yeah, so this is the MATLAB UI screen. So I'm sure most of you all here know what MATLAB is, right? So this is one of an example where MATLAB is used for augmenting the reality, right? So this might not be what you can expect, but then this is just a start as to what you can do, right? So using MATLAB, you can also access all your cameras. You can use USB webcams as well, right? So if you want to do such a type of a model, right? So first I'm loading all the functions, connecting to webcam, and then segmenting snapshots. All right. So the same workflow which I showed you in the presentation. Let me just run this and show you how this looks like. This might take a little bit of time in terms of loading. So you can try in between, right? So you have the drive file. So anybody having any challenges as to uh, loading the files, please let me know. right? So the first thing what the file is asking me is to choose a desired background, right? So I already have, you can see I have four different types of background already images which I have in my workspace. I can just type in 1 2 3 4, either one of which I want. So let's take the Apollo one, which is in space. And then what it will do is it is actually capturing my face, and it is actually superimposing my face into the virtual background what we have, right? So this takes a little bit time, so a lot of image processing and such things are there. So typically you use engines such as game engines such as Unity, Unreal, and you develop such 3D environments, and then you would want to do a real one, right? So this is, you can see me in real action. So I'll ask some questions, but then you can see that I'm actually speaking, and I have the background at the back end. Right. So this is one way of augmenting myself to the complete reality. Again, this is just a 2D image. We can do it on 3Ds as well, and then how to take it further. Right. So this is one example just to show you all how it is. Right. So so quick questions for you all. You can use this. Right. So how well does the algorithm segment you from the background? Right. So and you can post your answers in the chat window, and then you can ask it so that it can be an interactive one. Right. And how does the lighting, resolution, etc. affect the results? Anybody has any thoughts on this? Do you want me to run the demo again? Yeah. So how does the algorithm segment you from the background? Yeah. I mean, it just yes. So that's a good point. And then we can also take put markers, right? So we can actually train the uh, object with different markers, and it can do that same as well. So how does the lighting resolution affect the results? Anybody want to answer? That's okay. I mean, even though if you're not able to, you can think of it, and then maybe you can put it in the chat window, right? And then we can take it further, right? So
Yes,
feel
more
free to
answers are
put.
there in the chat window, sir. More answers are there.
Yeah. Okay. Yeah. So these are all some ways as to what can be done, right? So if you look at the logic itself, so this is something which is exactly what is being done at the back end, right? So please let me know if you're able to access the files, or you can download it, and then later, maybe later, you can play around with it, right? So this is a working code which you can do, right? So so I've shown you some a live example of a use case where AR can be used, right? So how can this be applied to AI, right? So so how can these AR type of a things can be applied, and how does AI has possible applications in augmented reality, right? So let's explore some of the cases here. So let's look at what AI itself is, right? So where is it applied, and do you think right? So that should be fine. Yeah. So do you think you experience the AI in real life, or is it a science fiction, right? So if you look at the applications here. So AI is currently grown from extensively, and nowadays, though AI is everywhere. Everybody talks about AI, right? So it has become a buzzword as of now, and a lot of young engineers are already being already learning AI in their engineering itself, or even more before. So most probably in the future, what we might have is more complex systems and more innovative systems which we can work with. So some examples here is autonomous driving systems, where again AR is a part of it, and it uses uh, what do you call AI systems or machine learning models to work with it, right? So we can use AI for face identification, and the applications here is enormous, right? So MathWorks currently is a leader of uh, the AI community. So it's being recognized as a leader for the second consecutive time. And why is that? I'll give you a glimpse of what can be done and what are the different options you have when you're working with an AI system, right? So how do you develop such AI models in MATLAB, and why is it so easy, right? And what are the different flexibilities we have when it comes to working with uh, MATLAB? So this is not from MathWorks. So this is from an independent analyst, Gartner, so which has actually recognized, and so that is it's an analyst partner, and they have recognized MATLAB to be done that, right? So you can also see many other competitors for AI engines. We have TensorFlow, and these are all open sources, but then professionally, if you want specific type of support, so you will eventually have to go towards paid software or a professional software to develop such systems, right? So that's where MathWorks come in, right? So if you look at the mega trend, so like I told, so AI is not a new thing. So AI has been there in from quite a while. So this is an old thing, and since because we didn't have much support in terms of computing in the past, so we were not able to achieve it in the previous years. But then over the years, we've seen how the electronic industry has grown, right? So with the advent of high speed interfaces, high speed hardware. So it has enabled us to work with machine learning and deep learning. So machine learning is again where we use data to identify some hidden patterns and then engineer features, and use those features and then create a predictive model, right? So this is completely on data. Since we are working on enormous amounts of data, we require huge amount of data power, and the computational power are required to us, right? So machine learning again, it's not self-served. It also has its flaws, and it wherever it's not able to cater out efficient logic or efficient models for specific environments, that is where deep learning comes into the picture, right? So wherever all those areas where machine learning is finding difficult to incorporate and give a solution, so deep learning comes there. So deep learning currently has thrived the industry to address a variety of complex solutions, and this is quite extensive and requires some time for us to get used to, but then this has a lot of potential, and in terms of non addressing non-linearities, and then a relationship between non-linear inputs and outputs, right? So that's where deep learning comes into the picture, and it understands what is required for us to achieve that specific result as an output based on whatever inputs we give, right? So let's look at the difference between machine learning and the deep learning, right? So one step that separates machine learning is called the feature extraction, right? So you can see I have input images, I have to manually extract these features, right? So in machine learning, the person or the system developing the model needs to inspect and understand the raw data to decide the specific properties of the data. All right, so this is an expertise which comes in from us, right? So we should know what features to choose, what not to choose, and which one will give us a good result, right? So once we have the manual feature extraction, right, so we can then use different types of machine learning models which are already there in the market, or you can create one of your own. I mean, it's up to you how do you want to use it, but then we have good sufficient machine learning models for us to work with. So you can create such type of models. You can use the existing algorithms, and then either you can do a regression type of a problem, or a classification type of a problem. So it depends on what you want to do here, right? So I'll take an example of AR, and combine it with AI as well. So I have a demo for that as well, where I'll be showing you how AI can be used in the AR aspect, right? So coming down to deep learning, the one advantage what we have with respect to machine learning is, uh, in deep learning, we don't have to engineer the features. We give in the raw data, and I mean, since it's convolution neural networks, it automatically extracts the features based on our filters what we give, right? So it automatically extracts features, and then it automatically understand what features has to be used to get a good classification output, something like this, right? So that is a major difference between what we have. I mean, why do we use machine learning and why do we prefer deep learning? Right, again, deep learning helps us, in various aspects, right? So this is a comparison between in terms of results, right? So machine learning is typically used for small applications where you don't have much computational power required, or something like that, right? So we get good results where we don't have much data. If we are working on a small niche area and we don't have much data to offer, right? So that is where we can actually go ahead with machine learning, because it gives good result if we have small data sets, and it's quite easy to train. So which are some of the traits of machine learning. So the disadvantages comes here when we where we need to actually get a good result or a good accuracy when we want good results out of it, right? So we need to select the features accordingly. Feature engineering is actually one of the key aspect when it comes to machine learning. If we don't engineer the features uh, in a good way, so if we have some unwanted features, so it will simply account for computational time, and also give you and not give you a good accuracy, right? So we don't have control of the accuracy, in fact. It all depends upon the model what we are training it with. So let's say you have a feature set and you're training one model, and if you use the same feature set to train a different model, you might get a different accuracy, right? So we don't have any control. So on the contrary, if you look at deep learning, so the one disadvantage there is we require a lot of data sets, a lot of data for us to work with deep learning, right? So the more data you have, the more better your accuracy is, right? So since we are working with a large amount of data, it's computationally intensive, and but on the brighter side, I don't have to engineer features, right? And you can also see that the accuracy is unlimited as in I can reach a maximum, I mean, I can reach up to 100% of accuracy if I have good data set, right? So for a specific application, if I have enormous amount of data, I'm bound to get a good result wherever I train that model and use that model, right? So that these are some of the major differences between machine learning and deep learning, right? So when it comes to deep learning, so neural networks are the major I mean, the architecture which is involved when we are designing these neural networks, right? So they are like our own biology, how our neurons are interconnected in our brain, right? So we have the input layer for our input data, and output layer is where how much number of classifications or regression what we have. So hidden layers is dependent upon what type of network we are using, and how many layers it has. So most of them use pre-trained networks which is already there, but then you can also engineer your own network from scratch, which will eventually take some time for you to do that, right? So now let's look at how we can build such AI models in MATLAB, and later, and I'll take an example as well. So this is just a brief introduction as to how we can build such AI systems in MATLAB, right? So when I talk about the algorithm or the design flow, so this is a generic design flow, right? So first and foremost is we need to have data, and we need to prepare our data for AI systems, right? So which is a key task for us. And when we prepare the data, we need to see what type of network we require. And if once after we've developed such machine learning or deep learning models, right? So we need to integrate it with the system, right? So again, after integrating it with the system, so if you have developed it on MATLAB, so how do you deploy? What are the tools we have to help you to deploy? Right. So I will dive deep into each one of these segments, and show you how and what tools we have to ease your process, right? So the goal here is to help you develop a good prototype, and very quickly as well, right? And also it has to be robust, and it has to be efficient as well, right? So I mean that has been a key issue when it comes to industry, right? So multiple teams has to rely on multiple other teams and wait for them to complete the previous task so that they can accomplish the, I mean, they can then complete their thing, right? So it eventually causes lot of time delays, and it leads to late arrival at the market. Right, so it's all about how much time we invest in developing. So we talk about technologies, we talk about the new advances, right? But one, how much time does it require for us to develop such technologies, right? So that is the key factor. So we should all, I mean, that is where MATLAB comes in, where which is a framework which helps us to actually address these development type of challenges, and using the functions and using the capabilities. We'll see how we can re-engineer and add new things to our models, right? So the first and foremost is the data preparation itself, right? So it turns out to be the most critical ingredients to success, right? So and this is very hard for us to actually capture the data, right? So lot of differences, lot of new things which can be done, lot of errors will be prone to when we are actually engineering the data which is required for us to work with, right? So this is an example from a student who was actually doing a PhD, right? So once a research scholar is doing his PhD, so most of the time is actually involved in building the model or algorithm itself, right? A little bit of emphasis is given on the data sets, right? So, but once after he graduated, finished his PhD, he got placed into Tesla. You can see the graph of how much time he spent on engineering the data itself, right? So most of the time is involved in capturing the data, because we already have a lot of algorithms which are there, and most efficient algorithms which are there in the market, which we can directly start using them for us to get good results, right? So it's about the application which we want to build, and then how fast we want to build, right? So you can see, but the major chunk involves in engineering the data itself, right? So one goal of data preparation is accessing the features, right? So which have the critical and high predictive value, and there again we have some features which are also unimportant, right? So let if we take an example from SNCF, so this is the French National Railway. So they build a predictive maintenance systems for their trains as well, right? So they collected a variety of data from both connected and unconnected trains, and use their domain expertise to process and analyze the data. Right. A simple example is creating a performance indicator called discharge or charge ratio, right? So derived from discharge values from the battery system. So this is just one simple example. So they combine their expertise with machine learning to derive a set of indicators that feed into a predictive maintenance system as well, right? So this is how they, if we engineer features. So we also have these apps, these labelers apps, right? So when we talk about data, we should also have labels, right? So we have apps. So take an example of such an autonomous driving system where you want to identify and segment out different cars, and this is an autonomous unit, and you want to overtake some cars, or reach a target in specific time. So you're optimizing your speed routes and how fast your car should go, right? So a lot of decision has to be done, and a lot of labeling has to be done, right? So if your algorithm wants to detect a car which is going in front of it, right? So you should put those into different labels, right? So we have apps such as image labelers, and video labelers which helps us in automating such tasks. We can use the GUI to apply these types of segmentation techniques, and then we can use it for labeling, right? So we also have a lot of apps which can automate for not only video image domain, it's also applicable for many other signal processing types of applications as well, right? So once you have developed your models and those things, right? So you should also test your algorithm, right? So again, for testing, you cannot possibly go and create a new test data set and then come with it. So again, which is time consuming, which is not usually recommended if you're working with the tight deadlines and so, right? But using MATLAB, you can actually generate your synthetic data, where you can use such synthetic data to give it as an input to your models, test models, and see the behavior, right? So you can actually do virtual reality type of applications as well. You can see these are all for automotive. So similarly, it can be done for aircraft, it can be done for missile systems, and also the lidar simulations for specifically autonomous systems, right? So you can create such 3D scenarios, and you can give the subject your, you can put your, let's say car, you're building a car, you're building an autonomous car, right? So you can put in input your autonomous car into such 3D environments, and you can see how your car is behaving, and is it able to perform a specific task, right? So you can virtually simulate it, and this actually helps you to prototype easily and efficiently, which where you don't have to do it manually, go to the ground, set up all your sensors and hardwares, and do trial and errors, right? So you can sit inside, use the software to manually do, automatically do that, and then you'll be able to get a good output from such types of models, right? So this is how you can generate data from MATLAB. So all these possibilities are there. So you don't have to spend much time in capturing the data, the raw data itself. So you can duplicate your work, and you can increase your productivity by using such options which are there, right? So the next one is the modeling of the AI system itself, right? So we have a lot of algorithms within MATLAB environment, so you don't have to load. So similar to your Python or other open source systems. So you'll have to first load your network. You'll have to call it from, let's say, your repository somewhere else, or you'll have to download it, and you'll have to call it, right? But whereas in MATLAB, you don't have to do that. You can directly uh, these are already there in the MATLAB UI. You just have to call those functions directly. So a lot of algorithms for machine learning, deep learning, reinforcement learning are already available. It's just that you just have to use it and build applications from it, right? So we also have pre-built models for deep learning, right? So we have all these networks. So AlexNet, again, AlexNet is widely used, and this was actually bagged the best neural network award in the year 2012. Right. So from then onwards, there has been a lot of advancements when it comes to working with AI systems, and we can see a lot of applications there, right? So it's we know how we can model these algorithms and pre-built models, right? So now how do we automate it, right? So if you want to write codes for each one of those, right? So it's quietly it's a difficult task for us to actually do that, right? So you need to have some automation frameworks which will help you to build such AI models very easily, right? So what I'll do is I'll just go navigate to MATLAB, and I'll show you a live experience of how MATLAB can automate developing these machine learning and deep learning algorithms very quickly. Right, so we have apps for machine learning and deep learning separately, and also if you want to work with neural networks, we have the neural networks app, right? So, yeah, so this is one thing. right? So these are the apps which we have for machine learning and deep learning, right? So classification learner is an app where you can automatically train various machine learning models with the data, raw data what you have, or the features basically for machine learning, right? And it automatically gives you the results, and you can also generate code from this. So it's all about click away as to how you work with it. So what I'll do is I'll just load one example for you all and show it to you, right? So as to how easily this can be used. Right. So this is a simple example. I'll not take a complex one. So I'm sure you would have known these fissurized data set, right? So I'll just take a simple example just to demonstrate this, right? So fissurized, what this data set is, I have these features of sepal and width, petal width of three distinct types of flowers. And I want to create a predictive model as to whenever I give the sepal length and sepal width of any flower, it should predict and give me the specific species, right? So what I'll do is I'll open the classification learner. I'll click on new session from workspace. I'll just select it as an input, right? So this is the input I'm using. So I'm just using two features from this, which is sepal length and sepal width. And my third, you can see the table is of three columns, right? So the third column is basically my response for each of the data what we have, right? I'll just use the default. So you can also set the cross validation. You can click on start session. You can see that a lot of algorithms are already available for you to train this type of a model with, right? So you can select them in the model type. You can select different algorithms which are there if you're not sure, right? So this is one question which we come across very often as to what machine learning algorithm should we be using, right? So how do we come to a conclusion as to what algorithm should be used, right? So how do we come to a conclusion, right? So using this classification learner, you can see that there is all option here, right? So if I'm not sure as to which model I want to use, I'll simply click on all. So this, you can see that it is taking around 24 types of 24 different models, and it is training for each one of those, and the model with the highest accuracy is highlighted here, right? So now you can see that how quickly I'm actually able to train 24 different types of classifiers, right? So with just a couple of clicks, right? And I can also see how the accuracy is for each one of those, which one is giving me the highest accuracy, right? So this app actually enables us to prototype models very quickly, and how to work with it, right? So this is a good model for me, so which is an SVM type of a model. So you can see the uh, scatter plot here, right? So you can also see it with model predictions, right? So wherever there is X, so that means that that specific point was misclassified, right? So this is a scatter plot. You can also use confusion matrix here to plot the confusion chart as to see how the data is done, right? So once you are happy with the results, so now you can click on any model what you want, so it will change accordingly. So now SVM is what I want, and you can click on generate function. You can see it automatically gives you the function how to work with it. All you have to do is just pass your data as an input to this model, to this function in fact, and it will give you the trained classifier, which is SVM in this case, and what is the accuracy, right? So automatically the code is generated. All you have to do now is just pass this flower sepal data, uh, right? So this is the data which I should be passing to this function, right? So now you can use this function for code generation as well. If you want to generate C++ code, you can go to apps. We have MATLAB Coder, and then you can You can use MATLAB coder to generate C code as well, right? So a lot of options which are available in the MATLAB UI for you to deploy these AR or AI applications as well, right? So similarly, if I want to show you an example of regression, right? So this is an example where I'm actually predicting the fuel economy of a specific car, taking into consideration these features, right? So I'll just simply run the whole program, go to apps. It's the same thing. So regression learner, once I have the regression learner open, I have to load in the features. I load it from workspace. So here in this scenario, this is my card table. I have 7 features with me here. So using these features, I want to predict what is the miles per gallon of my specific vehicle, right? So now this is a regression type of a problem because I'm actually predicting a value, output value, right? So I'll click on start session. Again, if I'm not aware of what model to use, I'll just use all the models and then try to get me an output. I'll click on train. So you can see that I'm training around 19 different types of regression models. And here the key parameter is root mean square error. Root mean square error is the difference between the predicted value and the uh, uh, output value what we have, right? So our goal is to reduce the root mean square error. The lower the root mean square error is, the better the performance of that specific model, right? So now you can see how quickly, right? So I was able to do classification, regression. I trained 24 different algorithms in classification, 19 different algorithms in regression, right? So in hardly 5 minutes. And I was able to also get the code, get the accuracy parameters, why I am going ahead with SVM compared to other models, because of the accuracy, right? And also I can generate the function from regression models as well, right? So I can automatically do that. I just have to save this function, use the function for its reciprocability in your future programs as well. Right, so this is how you can use MATLAB very quickly, and this is a development type of software where you can build algorithms, models, and simulations as well. Right. So anybody has any questions in between, please feel free to voice out. I'll be happy to take questions, or you can put in the chat window. I'll answer those in the uh, at the end, right? So this is how you can work with classification and regression. We also have an interesting app for deep learning where we have the deep network designer, right? So this is helpful for us in visualizing the uh, networks, right? So you would have been built neural networks, let's say of 25 layers, right? So what we'll do is we'll take the AlexNet as an example, right? So I'll take the same AlexNet as an example. I'll show you how each of I'll show you how each layer, what is the different uh, configuration of each one of those, and then how do we take it further, right? So what I'll do is I'll just clear my workspace. I'll create a net called AlexNet. So I have the AlexNet variable in my workspace now. I'll go to my deep network designer and I'll load from workspace, right? So I have a series network. So we know AlexNet is of 23 layers and excluding the input and output layer, right? So now you can see that the whole network has been imported here as a flowchart. So all the arrows shows us how is the data flowing from one part to other, right? And each layer, you can click on it and you can see the properties, right? So now this is the input layer and you can see what is the input size which has to go in. So next is the convolution layer, how many number of filters, how many outputs I have, right? So I have around 96 outputs from this, 96 features from this convolution layer. You can see that I have multiple convolution layers as well, right? So this is already exploring what network I already have, the deep neural network which already I have, right? So let's say you want to create your own deep neural network, right? So let's say you want to work on images, right? So you can add an image input layer. So then let's say you want to put a convolution layer and then ReLU, softmax, fully connected, all these things. You can just drag and drop it from your left-hand side, right? So you have all this max pooling, yeah. and then we have the softmax and then the classification, right? So this is the simplest layer which you can build, simple convolution neural network layer which you can build. You can drag and drop it and connect all the models here, and you can specify what data you want to use for training. You can specify the training options here. All right, so what solver to use, what is the learning rate, what is the batch size, right? So all these parameters can be given here and you can train it, right? So everything in a graphical user interface. You don't have to code anything. So this is again widely used by scientists and engineers to quickly prototype for time constraint models. This can be used for your applications as well. I'll be very happy to showcase more on these things. So again, so let's get back to the presentation what we had, right? So this is how we have different tools for us to work with different algorithms, pre-built models, and those things, right? So this actually increases the productivity of designing and analysis of specific models as such, right? Uh, uh, but what this AI training does is, so here, if you look at the example which I took, I only had small, I mean, very little features here, right? I had 150 or 200 so features what I had. But when it comes to actual AI, right? So you'll be working with huge amount of data, and I didn't train here, right? So if even in the deep network designer, I didn't go ahead and train the model, right? So let's say you even have like 500 or 1000 images. It will take you I mean, if you have a good graphic card and a good processing system, it will take you eventually at least 2-3 minutes of time for it to train for the different images what we have, right? So in order for you to help you in terms of accelerating the training process, right? So we have interfaces with Azure, Docker, AWS, and NVIDIA GPUs, which can help you to accelerate the process of the training. Right. So with collaboration with such technologies, you can utilize these resources and data centers to accelerate the training process. Right. So typically in an industry level, so they'll be working with lakhs together of images, huge data sets. Right. So it will take weeks or let's say months together of time for them to train one model on all the data set what we have, right? So they will be requiring good system, good computationally intensive systems for them to accomplish such tasks, right? So again, MATLAB has support for all this. Again, we are not in competition with the open source. I mean, MATLAB has is connected with Open Neural Network Exchange, where you can import your open source networks, custom networks which are openly available in the market. You can load them onto MATLAB, and you can export MATLAB models to, let's say, Python, and by using Python compiler and those things as well. So it is completely interoperable between the technologies what we have, and then you can work with it as well, right? So this is how you build your AI models in your MATLAB. And once you build your models, so now that is again the starting step, right? So you have built a classifier. So now the next step is to integrate it with the system design, or in the complete system what we want to build itself, right? So here in MATLAB, we have the model based design, we have the programmatic environment as well, which helps us to actually combine such complex systems, multiple systems, and then interact with each other. I mean, get them to interact with each other and then work with them itself, right? So this is an example from Voyage, right? So it's a small startup company who makes self-driving taxis for retirement communities. So they developed a level 3 autonomous vehicle in less than 3 months. Right, so that's astonishing. So in 3 months, they were able to develop this self-driving car, right? So they had an integrated model that spread the process of from the idea to road testing using Simulink. So using the real time prototyping and development, hardware in the loop capabilities, so they were able to build this whole complex system in less than 3 months, right? So it's not only that. So if you want to, let's say you want to identify faults, any mission what we have is subjected to wear and tear, right? So we know that, and any machine we have right now overuse over time and over usage of it, they are all prone to some errors and some
அண்ணா
defects
எனக்கு ஒரு டவுட்.
as well.
அந்த பிள்ளைக்கு வர ஷேர் என்ன கொடுக்குமா? அப்புறம் எப்படின்னா எனக்கு வர ஷேர் அந்த பிள்ளைக்கு நான் கொடுப்பேன்.
Hello, please mute your mic.
ஆசைதான். அந்த பிள்ளைக்கு வர ஷேர் எனக்கு கொடுப்பீங்க, நான் தனியா தானே.
Sorry, sir. You can.
No problem, sir. No problem. Yeah. So I was talking about generating synthetic failures, right? So you can see this in live action. So this is just a pump. So what they're doing is they're manually adding defects to these simulation pumps, right? And then they want to see how your model will work in such failure environments, right? So what is the simulation? What is the output of such a machine will be uh, if such a failure is occurring, and then what should the machine be doing if such a failure occurs, right? So you can simulate, you can generate synthetic failure data as well. So previously we saw about how we can generate synthetic data for testing, right? So you can also generate synthetic data for testing your failure data as well, right? So this actually helps you and in testing your system for robustness, working with different environments and different fault conditions. What is the expected outcome if such a fault is occurred, and how do you reduce it, right? So these are some of the questions which you can come up with when you're designing such a system as well, right? So we can again accelerate it with we can automatically generate code, which I talked about as well, using MATLAB code. We can also generate HDL code, and this thing, I think I have one slide there, right? Yeah, so this is one. So using the once you have developed the system design, you would want to integrate and build a hardware or a prototype and then see it in live action, right? So we have code generation capabilities. All your MATLAB and Simulink models can automatically be generated, converted to C, C++, HDL, or such as VHDL Verilog, or any other language such as CUDA, if you want to target your GPUs, right? So NVIDIA, AMD, Radeon, graphic card, whatever is there in our systems, if you want to interface those and then use their resources, right? So you should be writing codes in CUDA, right? So MATLAB and Simulink automatically does that in the background, and it helps you to work with it, right? So given the introduction, I mean, as to how AI is, right? So what MATLAB has to support you in terms of development of AI system. So now let's try to apply the same for the same VR type of an application, right? So we have seen. In the next exercise, what we're going to do is we're going to use a deep neural network to classify your posts into one of the 5 categories, right? So some systems are already using technologies like this in sports. Pose recognition can be used to track the motion of athletes across a field. In robotics, more specialized systems for hand recognition and can be used for remotely control robots. In AR VR, you could do something similar using a pose, using your pose to control some aspect of your virtual environment rather than a physical one, right? So again, all this Pokemon games and all this gesture controls, right? So they all take pose, I mean, taking what is it that you're trying to do as your input, right? So let's take a look at the code again, right? So now here what I'm doing is I have AR at the background, and in that AR I'm actually predicting what is that specific person giving me as an input. I'm classifying the pose here and then taking that as an input, and based on the pose I'm actually augmenting some new things. I can do anything later in the further, right? So depending upon the scenario, depending upon the application, depending upon the app, so this can be used as an input, right? So again, if you want to detect all these poses, again, I mean, we will eventually be using machine learning and deep learning at the back end, right? So now let's take a look at how we can do that in MATLAB as well, right? So let's take a look at the code again. So which again I've put it in the drive folder for you all. Right. So these are the highlights just to see. So we it will just ask you for a prompt of your labels, right? So you take a snapshot right? So again, it's all video processing at the back end, right? So 30 frames per second means 30 snapshots for each second, and each frame is eventually captured. I mean, used it for image processing or deep learning applications to do predictions, and then yeah, I'm actually doing something else, right? So it's all video processing at the back end. Eventually, you can see multiple technologies are connected here when we are working, and the visualization itself is an optic related area, right? So they use a pair of glasses for us to illuminate and give a 3D dimensional view, right? So that is again one more domain of physics which comes into the picture, right? So this is what I'll be doing. So I'll capture the pose and then classify it, and I'll also do that in MATLAB, right? So let's go back to MATLAB here and try out the first exercise. All right, so this is the code I have. So you can access it from the drive. You can let me know if you are able to access it. If not, maybe at the end of the session, I'll show you how to access the files and how do you copy it as well. Right, so let me just run this. So this is a complex one as well. Again, I'm using a lot of things, right? So what is it asking me to do now is it is asking me to label the different types of poses, right? So this is one type of pose. So I can just tell that. So this is hearing pose, right? So this is one type of a pose. So maybe this is observing. I want to classify this as an observing, so maybe this is glancing. So this is saluting. And this is buying, right? So once I have specified the different types of poses which I want to identify, right? So now this will invoke algorithm at the backend. So now what it is doing is it is actually loading my video webcam, and then whatever pose I do, right? So it is actually scoring according to my model. So if I do buy here, so right, so it is actually scoring it as buy, right? So you can see it will take some time to predict it. So at the back end, it's all VR, AR, and how we can work with it, right? So this is the system. So you can try this once we are doing on your own. So you have the code with you all, you can try this. Also, this code consists of a lot of helper functions. So this is not a simple code. So you can see a lot of helper functions, a lot of functions are there at the backend where it's automatically training the model with the different types of poses and with the names which I give it as an input to it, right? So that's how you can build your AI systems as well. You're using you can combine multiple environments typically, right? So that is an example. So quick question to you all. So anybody want to take a guess as to how well does the model recognize your pose, right? So what are the different aspects when it with related to the example here, so what do you think? How did the algorithm behave? So did you identify any flaws? Did you identify anything which can be improved? What are your thoughts on the video? Do you want me to repeat the whole section? That's okay. So put your views in the chat window. I would want to hear from you all. So that's right. Yeah. So if we had more data or more type of classification, you can also see that there was a lady's which image which it was trained to, right? So now I'm a different person. I'm a new data to the model, right? So again, more data. That's a good answer. Uh, that's right. Yeah. So it requires more training set to get a better result. So which is obvious, right? So that is where we talk about data, right? So that is where data comes into the picture. So can we explore the internal decision-making phases of the models in MATLAB? I'm not sure exactly, sir. So what is it that you want to see? So this is from Senthil Kumar, right? So if you're creating your own network, so then you have flexibility of assigning whatever internal decision you want to make, right? So if you're using the pre-trained models, so then though they will come with their own internal architecture and internal decision system. So you can replicate it. You can replicate the same and then put your changes as well. So yes, you can do that if you're replicating it. You have flexibility to do that as well, answering to your question. All right. So now let's recall so what we've done so far, right? So in the previous two sections, what we did is we obtained definitions and explored how AR and AI can be used separately, right? So in the next section, so what I'll do is I will see how AR and AI can be used together, which will lead us to the third and then the final topic, right? So which is the challenges what we have in AR and AI, right? So we saw with the help of an exercise where AI is specifically being implemented using deep learning to classify the various poses, right? So a quick question again to you all is the pose classification which I used, right? So can pose classification be used for another application? So what is the application which you think it can be used as well? So can the pose classification algorithm which I used have potential other applications as well? So what do you think what other applications might be? That's a great answer. Yeah, so you can use it for traffic cameras and traffic policemen as well to identify what it is. So again, typically for autonomous driving systems, identifying the poses. That's a good answer. Yeah. So any other thoughts? Anybody else want to put in something? Yes, object recognition is a concept itself which we are doing eventually. Yeah, but for applications. So I'm talking about application perspective as to where else, what else do you think these poses can be used for?
Child care, old
Yes.
age homes,
Sorry, sir.
old age homes, child care.
Yes. Okay, old age homes, right? So yeah, for to helping the old people with their needs and something like that, right? So that's also a good thought. Yeah, that can also be used. So online purchase, extracting information from echoes in defense applications. Yes, so in defense, I'm glad that you brought it, right? So again, defense is more of security and surveillance and those things, right? So let's see one example there as well, right? So glad you brought the defense aspect, right? So it can be used for classifying poses in AR as well, right? So in this example, we see on the slide, so it provides 14 points uh, which provides an uh, different aspect, right, as to identify whether that specific pose is a violent pose or not, right? So this approach uses 14 key points in on our human body and categorizes the violent poses such as strangling, punching, kicking, shooting, or stabbing. Right. So this is the similar exercise we ran just now for pose classification. So this is just an extension as to how and what it can be. Right. So again, one more quick question is, could some of these perceived violent poses have a different meaning in different environment or context, right? So this is a typically a violent pose which we have extracted our data with, right? So can you think of any other environment, right? So this is again completely with respect to the background, with respect to the context as to what it is doing, right? So could the same pose have a different meaning in a different environment or a different context? What do you think? Do you want me to repeat? So my question is, so this was a violent pose, right? So his is actually attacking or something like that, right? So can the same pose be used in a different context? So this is classified as a
Act-
violent pose, right? So
Actually, sir,
yeah,
the context is it depends upon the facial expression and based on that the accuracy can be improved.
true,
If it is a smiling means it can be hugging also. If it
true.
is a frightening expression means it can be that stabbing pose.
True. That is absolutely right, sir. Yeah. So that is something which we can do. But what about the environment, right? So let's say the same pose if is in a if is in a different environment. So let's say he's in a gym or he's doing some he's practicing some martial arts or something like that. So there it's a different perspective altogether, right? So it's essential for us to build algorithms. So the reason I asked is, so there can be misclassification. So though it is a violent behavior and all the same expression, facial expression, it can be looked violent, but then if it is looked at a different context, right? So, but just by changing the background, the whole scenario of what we are actually trying to predictive changes, right? So that is also one of the challenge which you might face when you're working with right. So even in the dance, yes, that's also something, right? So it can be a dance position as well. So it can be categorized as a violent classification, right? So these are some of the challenges where if we are just changing the background, you can see that the model will actually find difficulties in classifying such types of things, right?
Sir, one doubt, sir. My chat is not working. That's why I'm directly asking.
Okay, no problem, sir.
Uh,
You can go ahead. Yeah.
Previously, that skeleton-based model is used. Now here, some point-based model is used.
Yeah.
Can you tell what is how to identify the points and those things, sir? Which one is better? These two modeling techniques.
It
One
depends,
is
sir. So,
skeleton-based, and another is key point-based.
yes. So that's a very good question, right? So again, these are two different separate techniques, if you ask me, right? So skeleton based is one technique of classification point, and this point based is also one more technique. So again, each one of those has its own pros and cons. So if you want to target a human behavior, so skeleton is something which you want to see how a person walks, how right? So how a person is interacting, what is his body language. So all those things can be easily classified using the skeleton based. Whereas if you use the point based, so I see some difficulties there for that specific type of an application, right? So these are both two different separate techniques for you to classify. It depends upon the application, which is best, right? So that is where the domain expertise comes in. Right. So that is again a very good question and a good challenge as well, right? So how do I select where should I go ahead with the point or the skeleton? Again, it's completely application specific there, right? So as to what has to be used.
Sir, skeleton based or key point based, this code is in MATLAB, sir.
Yes. I mean, you everything all the demos what I'm showing, everything is in MATLAB.
Okay, sir.
Right, you can access the codes. So I'll show you how you can access the codes. If not anybody, I have created a MATLAB drive link. You can download it and you can play around with it in the future. But whatever I'm doing as of now is completely in MATLAB.
Sir, another doubt, in what way this is related to augmented reality, sir?
Yeah. So So this is like an AR system. So you'll be walking with an augmented reality, right? So that in terms of applications, a lot of possibilities. So this might be a niche area, right? So in augmented reality. So let's say you're doing a surveillance system. So you are actually using a goggle somewhere there, right? So in working, I mean, as traveling in the real environment, and let's say you are identifying something in a far away, right? So I'm this is something which I actually telling to you in random, but then this can be a niche area. So you can augment it in the real time and see whether you'll have to fled from that place. If it is a violent environment, do you want to be going inside or anywhere near the vicinity of a violent environment? All right. So these are some things for security aspects which you can superimpose the AR and AI things. Right. So there is no limitations as such. So this is just one potential niche area which can be used. That's what I meant to say here. Right. I hope your question was answered.
Okay, sir. Okay, sir.
So in the next exercise, again, what we'll be doing is we'll be using deep learning to classify poses in different scenes as well, right? So again, this is I'm just labeling the background, prompting for background snapshots, segmenting it, superimpose, and doing a classification similar to what I did, right? So I previously what I did was it was a major the a normal image which I did. So here in this scenario, I'm just augmenting it to my background which I'm selecting, and then I'm doing the same. So it's just combined with the first and second. Here. Right. So this is the third exercise which I have. So it's asking me to select the background. So I have two backgrounds. So let's just take the second background itself. Right. So you can see it's loading the models, all the position models, all the neural networks, right? So it's connecting to my webcam, and then it is eventually posing, right? So it's actually doing a skeleton based approach, right? So it depends upon the background who I am. So it's currently only detecting my face, you can see, right? So it's accurately actually detecting my eye base here. So I'm very close to my vicinity. If I go back and see, you can see the whole body is actually detected, right? So it's also dependent on what is the background pixel and what size of input image I'm capturing, and everything comes into the picture. So if my it's all about my pixels in what we have, right? So these are some potential applications. So some examples which I found will be very relevant to the sessions what we are doing as of now, right? So again, quick question to you all. So how well is the algorithm able to segment the user from their background, right? So you saw the real time video capture and the segmentation, right? So how well do you think is the algorithm able to segment it out from their background, right? So how is the lighting resolution? Again, the same question. And did the classified result fit in within the content of the scene where you were located? So just take 1 or 2 minutes to put in your views as to what has happened and what can be done. Right. So you can have a thought of it. You can ask these questions to yourselves and improve the model later on. Right. So let's look at some of the results what we saw, right? So some poses were not correctly classified, that's obvious, right? So based on the scene, does the pose fit within the context of the scene, right? So based on the scene, you can see the segmentation, right? So that was also not complete segmentation, and something of that was to be done. So who is the determining how a post should be classified? Again, so here this is the logic what we are doing, and again we are only determining, the programmer is determining how a post should be classified, right? So it's on the data, on what data we are we are using to train the models, right? It's all about that, right? So what is our responsibility as we not only create this technology, but as we test the technology and use the technology, which can have a very severe real world consequences for our fellow human beings, right? So there are a lot of questions as well when it comes to AR, right? So since it is since we'll be wearing it as a wearable, so it will have direct influence on our human perception, right? So it will have direct influence on how we behave. It will how we react to our neighbor, to our environment, right? So all of those is affected when we are actually using VRs, right? So our knowledge base is also constrained to some of the virtual environments, and it can be a boon as well as it can also be something which is not being, which can have drastic after time effects as well, right? So I'm sure most of you would have seen the movie Surrogates, right? So where each individual has its own robot which they are controlling, and they have a dual life, right? So I also have some interesting applications here which I could find out, right? So this is one example. So class VR is very new now. So class VR is where the students get to see a real sense of 3D vision. So Facebook is coming up with the Facebook Horizon, where you have an augmented reality there, where it is a virtual reality in fact, but then you manually will be a different character in that reality, and you'll be interacting with other people with the different characters in that specific reality, right? So you can be on the moon, you can be on different planet, you can be in a different area altogether. So this is currently being developed by Facebook Horizon, where I think very shortly you'll be able to experience firsthand AR VR technology as well, right? So this is again one more example from Google Lens. So VR 360 you would have seen, right? So 360 is where you can use the VR 360 to go to any location and get a three-dimensional 360-degree view of the whole area, right? So you can go to remote locations, experience different uh, experiences without actually being there, right? So these are some of the applications which has potentials in that, right? So coming down to the challenges, so there are many challenges regarding the AI, right? So the terms in this cloud highlights themes that many of us have heard, seen, or possibly experienced, right? Some of these words highlight issues that are technical in nature. However, others highlight different types of issues as well, right? So these challenges in AI field are identified and documented in a different literature, right? So why should I be caring about these challenges, right? So anybody want to take a talk on that? Anybody would want to put a thought as to why should you be taking care of such challenges? Right. So these are major concerns basically if we look at usage of AI, right? So we can have identification efficiency there. So we might give rely a lot on logic than to give a benefit of doubt, right? So which can be something like that. So accuracy content algorithms, so again it varies on different types. It might not be most, it can be, might not be more accurate. And bias, discrimination, justice, again is a different challenge if you want to address all those things, right? So believe it or not, so we are all impacted by these challenges. More organizations of various type are increasingly relying on AI to assist and make key decisions that impact all of our lives, right? So for example, AI is used in variety of ways to suggest products for purchase, to determine if we can get a loan, or propose if we are more likely to commit a crime, right? So this leads to question as that can help us guide our thoughts and actions in terms of how we can counteract these challenges. So first and foremost is how can I get involved, right? So if you are interested in AR and AI, right? So how do you want to get involved with such of this, right? So there are organizations that can be leveraged to get involved, to learn and provide guidance to how we can take action, right? So according to the Algorithm Justice League website, all of us can become agents of change, right? So accountability and justice, plus advocating for other goals with respect to implementation of AI, right? So you can consider joining these organizations to learn more and create the implementation plan to take action, right? So we can help you out with that list as well, right? So once another question is, how do we get involved? Who is involved in creating the AI, right? So too often members from underrepresented groups in tech are not involved with different phases of AI design cycle, if at all, right? So when this occurs, so there are many perspectives that are missing with the creation and usage of AI. Right. So one recommendation that can be identified regarding this question is to actively recruit members from underrepresented groups into the tech field who will be empowered to be involved with AI development cycle and not just their data. Right. And also, what about the data? Right. So AI practitioners should pay more attention to the following, which is what is the source of the data, was there any bias in labeling the data, right? So how do we help ensure fairness in how data is labeled, who is labeling the data, right? So this all impact the outcome of the whole model which we want to build itself, right? So it's essential for us to take care of these questions, right? And the final question is, can we address these challenges with AI, right? So the answer is we can. So I'm hopeful AI is around us, but it is not a responsibility of a single person, but a community, right? So now more than ever is a time to raise awareness, discuss, and implement actions to address the challenges in AR or AI, especially with respect to bias, right? So this is a multi-layered problem that entails that all of us who from various sectors in society need to collaborate and address the challenges with AI, right? So some of us may be thinking, what can I do or how can I get involved, right? So you can reach out to us. So how do, if you are planning to get involved with this, so you can take up these few call to actions, right? So you can continue to learn and explore the usage. So list some organizations where you can join and actively work to address these challenges. So get involved and speak up various spaces where AI is being created or used, or you can volunteer or mentor to bring representation, right? Again, these are some examples of AR and taking decisions. So this is again semantic segmentation, where the green road represents the where autonomous cars can go ahead, and the blue and all are basically our cars, right? So basically, these are the enablers for us for deep learning. So we have the GPU acceleration, we have access to world-class models and frameworks and labeled public data sets, right? So now the big question arises as to, hey, I'm interested in doing this. So how do I get started, right? So how do I get trained? How do I know what I'm getting trained with is the right content, right? So so these are the on ramps which are there. So you can go to the MathWorks website. Yeah, so this is the MathWorks website. You can go down to the training section, right? So and you just have to create a MathWorks account. You have access to all these on ramps, right? So these on ramps are free of cost for you all. So you can take up machine learning, deep learning, reinforcement learning, image processing, signal processing, right? So we have around 11 on ramps. Upon completion, you also get a certificate from MathWorks where you can show it as a course completion, where you can get it. So this is internationally recognized and a valid certification where you can put it in your resumes, right? So if your college is under campus wide license, you also have access to all these premium courses, right? So this you can see deep learning with MATLAB, right? So let me show you how the progress report, what and all you'll be doing, right? So this is roughly around 15 to 20 hours in-depth course, hands-on course you have, right? So you'll talk about interpreting network behavior, creating networks, how do you train them, how do you improve the performance, How do you use deep learning for computer vision? How do you classify sequence data and classification data and all those things, right? So this all comes with projects at the end of each section, and this is a hands-on course. So this is available only as for the campus-wide colleges, right? Again, these computational mathematics and courses as well, right? So you can go through these things, but if you don't have if you are not under the campus-wide, if your college is not there, so please use the MATLAB on ramps to get started, right? So this is where you can get started, and then you can write to me if you are feeling stuck anywhere, right? So you can write to me any point in time for any technical related queries on MATLAB or Xilinx related products. I'll be very happy to help you and collaborate you on your research as well, right? So also I'm just posting the feedback form from CoreEl in the chat window. Request all of you to put in the feedback form, submit the feedback form, right? So this will help us in our future endeavors and to improve for our further future engagements. All right. So I'm open to questions now. Anybody has any questions, please feel free to voice out.
Sir, excuse me, good morning, sir.
Hello, sir.
Sir, myself, Dr. Jason Kumar. Sir, may I know how IoT can be integrated with the AR and VR? What sort of applications can be supported?
Yeah, I mean that's a good question. So let's say if you are doing such pose recognitions or object tracking, right? So or something you want to communicate, so you can take that as an input, and you have a platform named ThinkSpeak here. ThinkSpeak, I think most of you all will be aware of, right? So which is an IoT analytical platform, right? So all these gestures and whatever operations you do on the augmented reality can be taken as an input, and you can trigger such these channels in the IoT ThinkSpeak, right? So now using this, you can react in different places. You can take input remotely, and then you can set a reaction in a somewhere else in the globe, right? So you can utilize this platform in combination with MATLAB or any other workflows, right? So which has a good list of potential applications for IoT as well. I mean, this is what I can think of as of now. I hope it was in sync with what you asked.
Yeah. But for IoT devices, there are separate hardwares. We cannot use that. Google glasses. We cannot use that Google glasses kind of stuff for uploading data to ThinkSpeak, right? How can it be integrated with the standalone hardware like Arduino or the Raspberry Pi, etc.?
No, we will require those classes. We'll require the virtual reality type of hardwares where using the augmented or the inputs. Let's say you have a third-party person who is actually guiding something to you, right? So you'll have to have a mechanism to capture such data and push it to the cloud. So if you're using mobile phones, and also I think you can develop an application to do that, right? So from there it is possible. So standalone here, you should give the flexibility. You should have that kind of an option if you're building custom boards there. Right. So I mean that's the possibility which I can think of. So maybe we can come get sync up offline, and we can discuss more about how we can combine as well. Sir.
Yeah, sure.
Right. So again, I'll be posting the feedback link. Right. This will you can give your feedback here. So I'll get your mail ID anyhow. I'll get in touch with you to help you.
Yeah, I already filled the form.
Thanks. So any further questions for me?
Hi sir, good morning.
Hello sir.
Sir, basically I'm mechanical engineering from mechanical engineering background. So we are actually thinking of introducing AR and VR for our mechanical engineering students. So in
Okay.
that regard, like what we expect students, I mean, what are the basic things we have had to incorporate, or how we can introduce this, I mean, in projects for the students? Because in mechanical engineering, we do very less coding. Students will do less coding.
Mm-hmm.
So
Yeah.
they,
So how are you planning? I mean, is this only for projects or for teaching purposes?
currently we are asking them for projects. So, but down the
Okay.
line, we might think of as a subject also.
Okay.
Because
You mean to say we are learning concept, right? So
yeah.
not a virtual reality classroom.
No, not classroom.
Not that,
For
right?
the
Yeah.
learning purpose.
Okay. So, I mean, I do also help with curriculums. I think this is a good lead for us, sir. So maybe I can talk about specifics as to how AR, VR, what has to be done. I'll also
Okay.
put my link mail ID in the chat window.
Yeah.
Right. So just, I mean, if you can write a mail to us, sir, I'll get in touch with you and maybe we can discuss on what are the things which has to be added to the curriculums. I can also involve MathWorks technical team and they can also put in their thoughts as to anything which can be done here in the AR field or not. Right. So maybe if we start discussing, it might be go out of sync with the session.
Okay,
So
sir. Thank you very much. I'll write a mail to you.
yes, sir. Yeah, that will be helpful and we can get offline and discuss on the same.
Yeah. Thank you.
Thank you, sir. Yeah, so if there are no questions, Professor Glan, sir.
Yes.
Sir,
Uh,
yeah, sir. Hello, sir.
Yes, sir. Yeah.
Hello. Yeah, can we run the examples given in deep learner designer without using GPU?
Sorry, sir. Can we?
Can we
Can
run the examples given in deep learning designer toolbox? For which do we need any specific hardware requirement?
No, sir. So I mean,
System requirement?
yeah. So system requirements, the better, the faster, sir. So if you have a
Okay.
low end, I mean, if you don't have a high speed system, still you'll be able to work with deep learning. The only catch is you'll
Okay.
be actually doing it slowly, right? So if you have a good system, the processing will be faster, right? So you can see this training option
Okay.
here in the execution environment. You can select whether you
Okay.
want to run it in a GPU or in a CPU. If you have a
Oh,
multiple GPU, or you can also have a parallel, I mean, high performance system. HPC is set up to
okay.
accelerate it as well, right? So you can select
I
any of.
have 16. I have a laptop with 16 GB RAM. Whether can I execute examples with my laptop?
Definitely, sir. Definitely. A minimum requirement for you to run MATLAB is 4 GB. And definitely for deep learning, you might require a little bit more things. But for 16 GB, mine is also a 16 GB system, sir. You can go ahead and you can work with deep learning systems.
Okay. Thank you. Thank you.
Thank you, sir.
okay. Thank you, Shashi. Thank you. Thanks a lot. That is really, it's a very nice session, and we have started the day with your informative and that like it's like in somewhat hands-on. Thank you. And any queries, my dear participants, please contact with the resource person whose email ID is displayed. And thanks a lot. Thank you, Boban. Thank you, CoreEl Technologies. And on behalf of the organizing team and Vimal Jyoti Engineering College, I thank you. Thank you for your good, informative session. And
I would,
yeah,
yeah.
okay. Dear participants, our next expert, Dr. Keyur Sorathia from IIT Guwahati has joined already. And so sir, welcome you, sir. Just you take a small break and join within 5 minutes, please. Don't waste his time. I request all of you, those who want to stay back, please stay back, or you take a small break and come back immediately. Already the expert is waiting, and it will take some 5 to 10 minutes to set up all the things. And so please come back around 11:15 sharply. We want to start the session. Thank you.
So I just wanted to check the.
Yes, professor, you check the presentation. Okay.
Yeah, I'll check the presentation as well as the audio quality. So basically, I'm logged in into my mobile phone as well as my computer, because often for Microsoft Teams, my computer mic does not work, or I don't know, people cannot hear me.
Okay.
So, but I think what I will probably do now is I'll share my presentation. So if the sharing happens appropriately, then I will switch off my phone. I will like shut down the app and see if the audio works from my computer.
Okay, sir.
I have some video also. My
Yes, the
presentation
presentation
is.
is now visible. Yeah, it's visible.
Um, I just want to understand whether you are able to hear the audio of the video that I'm going to show. Can you hear any kind of an audio here?
Uh, no, it's not audible actually,
Okay, let me do one thing. Let me just.
but video is playing. Yes, sir. Yes, sir. It's audible.
My name's Loz Blaine. I write for Gizmag's emerging technology website. We're here at the Ford Immersive Vehicle.
Yes.
No, the audio is was playing, right?
Audio is. We are hearing it.
Okay, okay, fine. I think then we are ready to go.
Okay, sir. Okay. Just we will start at 11:15, sir. Okay.
Sure, no problem, no problem.
Okay, sir. Yes. Thank you. Shubha, shall we start? Shubha, are you
Yes,
there?
sir. Yes, sir.
Okay. Okay.
Okay.
On behalf of Jyoti Engineering College, I welcome you, sir. Now, over to Mustafa to introduce our guest.
Good morning to one and all. Virtual reality is a medium means by which human can share ideas and experience. Here we have a Dr. Keyur Babulal Sorathia to give valuable insight on the topic virtual reality, use cases, challenges, and opportunity areas. Dr. Keyur is currently working as an associate professor in the Department of Design DoD Indian Institute of Technology IIT Guwahati. He founded EI Lab around 8 years ago. He holds PhD in Gestural Interfaces for Resource Care Regions from IIT Guwahati. He holds a master's degree in interaction design from Interaction Design Institute, Domus Academy, Italy, and a bachelor in electrical engineer. Keyur and his projects have been awarded several national and international accolades, including the Erasmus Fellow, IBM SUR Award, Top 3 Innovation in India, GTVI, and many others. He presently takes courses on interaction design, tangible user interfaces, and HCI in virtual reality for undergraduate, graduate, and PhD students. Cure is found either on the sports field, dabbling indoors with PlayStation, Move, or Kimet VR, health apps, accent trick shot at carom, or trying weak skill on chess. I consider it a great honor to welcome Dr. Keyur Babulal Sorathia.
Oh, I hope I'm audible. So thank
Yes, sir.
you for the introduction. Yeah, thank you for the introduction. So I don't know where, I think you took it from the lab's website. It's pretty old one. But no, but thank you so much for this elaborate introduction. So what I'll do it is probably I'll share my screen and tell a little bit about myself as well. Yeah. Okay, great. Yeah. So as I was introduced, my name is Keyur, as in Babulala is my father's name, so you can just simply call it Keyur Sorathia or Keyur. That's better. And I am associate professor with IIT Guwahati. Uh, I was I just joined the last presentation, so I just want to mention over here is my talk is going more towards human-computer interfaces. So we will not really be talking about technology as such. Of course, technology is a very strong component of HCI, but the large or the whole presentation is about how we use technology for humans or whoever the users are. Uh, including concepts of user-centered design and so on. So it's going to be from an HCI perspective, human-computer interaction perspective, rather than a technology perspective, because that's what my research area is, and that's what I have been working on it for almost a decade now. Um, so yeah, and I run this lab called Embedded Interaction Lab. You just search on Google Embedded Interaction Lab, and you will see the website link, and you'll be able to see all the projects and everything over there. So what I'm really going to talk about today is sort of giving you an overview about what VR is, which I'm sure a lot of previous speakers have also given. So I'll maybe uh, quickly rush through that, and we'll be talking about some of the challenges and very recent application areas where virtual reality has shown great potential in terms of its effectiveness, efficiency, and delivering what user goals are. So we'll be talking about that. So um, generally when we look at, so I always start the presentation with being a little more interactive. But maybe we have a little time, so will not be interactive. But in case if you have any questions in between, as in, so you can interrupt me and you can ask questions. So, virtual reality in general has variety of forms. Generally, I've seen people consider head-mounted displays or something that you wear it on a head as VR, but there are wide variety of virtual reality applications or virtual reality platforms, tech platforms itself exist. So the first one, what you see is basically a head-mounted display-based virtual reality. The second one is more like a multi-projection based virtual reality where you are not wearing anything on your head, but you just have projections around you. So two or three large projections are there, and sensors are there to track your body movement. Like in this particular case, you have treadmill that basically is connected to computer, and your running speed shows some kind of an effect on the screen. Then there are other kind of virtual realities which are not very commercially known, but in case of research and collaborative VR, this is very wide use. This is called cave-like VR, which means it's basically a cave setup. You have projections all around you on four sides, sometimes in cases of six sides, even on the ceiling as well as on the floor. And this is what we call it as a cave VR. But this is again another form of virtual reality. Then this is a very old form of a virtual reality, largely not explored in today's world. But it's a desktop based VR where you have something on a desktop, 3D contents on the desktop, and you have some glasses which you can wear it and experience 3D content in virtual reality. Of course, it is not fully immersive as what head mounted displays or cave like environment can give, but this is also another form of a virtual reality. So just to formalize what virtual reality is, and I'm talking about two major definitions over here. The first one is purely talking in a sense of the senses that is involved in any kind of a virtual reality platform. So it says that it basically is an interactive computer simulations, largely in form of a 3D simulations that senses participants' positions and actions and provides some kind of a feedback that supports one or more senses and eventually leads to the feeling of being immersed or being present into the simulation. We'll come to what is being immersed or what is being present. But in this particular definition, what it says is that when it comes to VR, we are purely talking about visual and oral stimuli. That means we typically have some kind of a graphics and auditory feedback coming from the visual from the virtual reality system. Then using that visual and oral stimuli, we immerse into the virtual environment. Nowadays we also see some kind of a haptic feedback that includes skin sensation or force feedback, that combines with visual and oral stimuli. Skin sensation is something that we experience it even on a computer using or on a mobile phone by having some kind of a vibrating feedback when we type a keyboard on a mobile phone or when we tap on a screen. That is what we call it as a skin sensation based haptic feedback. And another one is a force feedback where in a virtual environment it feels like you are actually holding a ball despite you are in a real environment not holding a ball. So it gives you some kind of a pressure or a force on your hand, and provides a lot more realistic feeling to the work. That is another modality which is currently very well explored. And other senses which are not very well explored now, at least at today's date, is vestibular, olfaction, and gustation feedback. But some amount of research is going into that direction as well. So that's the definition from a perspective of uh, different senses that are involved in virtual reality. The second definition sort of goes a little beyond senses and talks about activities that virtual reality platform supports. So what they call it is basically computer generated 3D environment, and often called a virtual environment VE, where user can navigate and possibly interact with the virtual environment, resulting in real-time simulation of one or more of users' five senses. And they majorly talk about two distinct different than the previous definition is about the ability to navigate inside the virtual environment which means I can walk, I can travel, I can find a way inside a virtual environment the way I would do it in a real environment. And second is I would interact with the virtual environment or the objects in the virtual environment the way I would interact in a real world setup. So that's two major distinct activities that they propose as a part of virtual reality, and they propose virtual environment as a core component of virtual reality platform. Now, there are two major things when it comes to any virtual reality, which onto which we generally consider whether the virtual environment or virtual reality technology or virtual reality application is good or bad. So the first one is immersion. Immersion refers to the extent to which a user is isolated from the real world. So if you look at these two pictures, uh, in one picture where the head-mounted display is there, you have a user completely immersed into a virtual environment, which means you don't see any component of a real world environment and you are completely isolated from the real world environment. Whereas in the second picture, you are partially isolated from the real world and from the real world environment. So this is where the immersion part of it comes in, and this is what we call it as a fully immersive system or a semi-immersive or a non-immersive system. So fully, the first one, the head-mounted display is called a fully immersive system, whereas the second one is called a semi-immersive system. And if we really go with the non-immersive system, then any kind of a 3D environment on a desktop is what we call it as a non-immersive system. But it's still debatable part. But fully immersive and semi-immersive are very well defined phenomena in terms of immersion in VR. The second one is presence. Now, I'm not sure whether any other speakers would have talked about, but this is probably one of the most important part when it comes to telling whether a particular VR platform or a VR application is good or bad. We'll probably come a little later about what is good and what is bad. But if you have a higher presence into a virtual reality application, the higher the presence the user has, the higher the involvement the user will have, and the higher the experience user will have about the virtual reality application. So presence is about the sense of being there, and the what typically presence include is that it's a sense of being in the virtual environment rather than the place in which the participant's body is actually located. So the moment you forget about the real world environment you are in, and the moment you more get involved into the virtual environment without realizing which real environment you are in, that is what we call it as a sense of being present into the virtual environment. um, a sign of presence is when people behave in a virtual environment in a way that is close to the way they would behave in a similar real life situation. So the virtual environment, the more the virtual environment is towards the real environment, and the ability to interact with the virtual world is as near to what you would do it in a real world environment, it is considered that the users will be more immersed into the system. So that is, or more present into the system, and that is what we call it as a sense of being there or present. So these are the two major factors when it comes to virtual reality, which is immersion and presence. Now, this is a very famous diagram about virtual reality, virtuality continuum. I'll very quickly go through it because I'm sure this is a very common diagram that previous speakers must have gone through it. But it starts from the real environment to goes to the virtual environment, and there are layers that are involved in between, which includes the augmented reality, where you have digital information augmented on the real world, where the real world is a lot more heavier component, and the digital world is just an augmentation of the real world and very tiny component of the whole area of augmented reality. Whereas the second, augmented virtuality, is where you have a equal mix of augmentation as well as virtual 3D simulated environment, and where you have heavily adopted virtual interface which are supported through real world component, whereas in the augmented reality real world is heavy. When we go to virtual environment, which is on the other spectrum, uh, that is where we don't have any kind of a real environment, but we purely talk about the virtual environment, a simulated or a 3D environment that we create. And this the application areas and the other set of content that I'm going to share is going to be purely in case of a virtual environment, not having included of any augmented reality or augmented virtuality as such. Okay. Now, some of the core application areas when it comes to virtual reality, and recently has not just from a research perspective, but even from a commercial perspective, where companies and industries have adopted virtual reality, are few of them include like a virtual reality films, especially some of the Hollywood films are also coming in the VR domain. Of course, not as commercially successful as any traditional Hollywood movies, but something going into a VR direction about movies. Then virtual prototyping, then training personal using virtual simulation, data visualization, VR for therapy, like removing fear of heights or removing fear of public speaking, etc., is something what we call it as virtual reality for therapy. And experiencing the unexperienced, which means how would a blind person really experience the world, is something that we as a sighted person cannot understand. So in such cases, it allows you to experience, put yourself into a shoe of a blind person and see the world around them. So that is what we call it as experience and experience. So let me go at least three or four of them in detail, because these are the areas which have shown tremendous potential and opportunity when it comes to not just research, but even in terms of commercial applications of using VR. The first, which is a classic genre, which is virtual prototyping. I'll just show you first the video, and probably then we go ahead with some of the benefits of what VR provides in the case of virtual prototyping.
My name's Loz Blaine. I write for Gizmag's emerging technology website. We're here at the Ford Immersive Vehicle Environment, which has been certainly the highlight of the tour for me today, because it's a virtual environment in which you can fully explore a car that doesn't actually exist. The Ford Immersive Vehicle Environment, or 5 Lab, is one of only 2 of its kind in the world. It's basically a big empty room with a seat and a steering wheel sitting in the middle of it. You can put on this virtual reality headset and a glove, which are tracked by 19 motion tracking cameras around the room in real time, and you're suddenly in a virtual showroom experiencing a car in 3D. You can walk around the car, get inside, inspect the interior, even press the odd button. Floating icons in the air let you change the colour options of whatever car's being displayed, and there's even the option for a transparent skin. You can hoist the car up in the air to walk underneath it, or plunge your head straight into the engine bay. The 3D models are incredibly detailed, right down to the engine parts, so you can feel what it's like to be a piston, or surf down the drive shaft if you like. Ford's design team uses the 5 Lab as a very early step in prototyping, before any physical or clay models are made. It gives them a chance to put each vehicle in a number of different environments and test out different ideas in terms of engineering or fit and finish without any waste. The experience of sitting in this rig is quite uncanny. The vehicles, in this case a Mustang, render in Ultra HD and respond to lighting and reflections as well as any video game. Ford doesn't seem to have any plans to make this a sales tool, but a 5 Lab would be absolutely stunning in a showroom. Mind you,
Yeah, so this is an older video, as in from 2014, where probably a car company created a prototyping tool without you really create any kind of a physical object. And that is not just with car manufacturing, but even all the expensive manufacturing places, virtual reality is extensively explored, whether it is design of submarines or design of aeroplanes or design of heavy duty vehicles and so on. So at least the companies in Europe and US have started using virtual reality to first prototype the whole concept in VR and let user experience it, or at least the internal team experience it, and then do certain modifications based on the feedback that we get, and eventually go into production, or eventually go into making a physical model of the car. So that is what we call it as a virtual prototyping. There are multiple benefits of virtual prototyping, and that's why it's very largely used in heavy industries for now. So First is it helps in viewing and evaluating the product from different perspectives, purely from an ergonomics or constructability or even aesthetic perspective. It helps discover little annoyances or bigger problems that changes the direction of the complete product being designed. It helps in understanding how easy it is to construct, maintain, and enable workers to experience it in a realistic manner. And in cases where you want to take user feedback, you can actually have workers or users coming and experiencing the product and looking at the probable problems they will have, and then put up requirements of modifications onto which goes into final physical product that we develop. So that's majorly being used when it comes to VR is virtual prototyping. So that's one. The second one is, which is a very strong application area again as virtual prototyping, is virtual training, and that's extensively used for products which are again very expensive products. You don't want the users to destroy the products, or you don't want the users to have any kind of safety concerns about the products before they actually start using the physical product. So then these kind of virtual training is given, which is basically a real world training itself. Only the components are 3D rather than the real world environment. So again, I'll show you one video about a submarine being used virtually before the officers can really start using the submarine. Just a second.
Our clients want to train people for anytime, anywhere. And the Immerse platform enables you to do that. It allows people to enter into a virtual world as a team and train together wherever they're located at whatever time. In current training, people aren't collecting data. Obviously, trainers are marking, but on the whole, there's not a lot of objective data being collected. But by this being on the cloud, there's an opportunity for us to collect that objective data and to actually adapt training, to personalise it, to make it slower or faster according to individual needs. And from an organisational benefit, that in itself is going to have a massive impact on effectiveness and also people's enjoyment and experience of learning.
Yes, so that's another area which is virtual reality used in virtual training. Um, I'll quickly go through the benefits that it has. Especially, it allows the ability to practice uncommon and expensive and dangerous tasks, which will be helpful to users in scenarios such as military, war, medical emergencies. US military, if anyone has heard, recently has joined with Microsoft, and before that also they had created virtual reality in-house ecosystem where the soldiers were trained in a combat-like situation. So virtually they were enemies and they were supposed to shoot enemies using real guns and all the real objects around. Similar way, recently they have given a project to Microsoft HoloLens, where the military will be trained using HoloLens, where the enemies will be virtual and they will be trained on that. Similar way for medical cases, where you want to have students to when you don't have real dead bodies. So in that cases, you train students about surgeries, anesthetic experiments, and so on and so forth. All the kind of medical requirements that the student doctors have. That is something that is also done using virtual training. It also helps us analyze the performance of the trainee and make better modules effectively and cheap. So you can actually have ensured whether the student is now ready to go on the field using these kind of training platforms. So that reduces a lot of cost of the company before the candidate really makes any error while using the actual product. Yeah, so that's about virtual training. Then the third very extensive area about virtual reality is walkthrough. So I'll again show you a video. Now, this is something a very cheap uh, tool or a very cheap platform. As in today's time, it is very cheap to actually download all these applications, virtual reality applications, and create walkthroughs. And this is something very fascinating that has been used in civil engineering, architectural spaces, history spaces, museums, and so on and so forth. So I'll show you a video and then probably we'll go with some benefits on this.
Look at your sky choice. Cloudy sky selected. Look at your sky choice. Sunset sky selected. Look at your sky choice. Night sky selected. Select carpet color. Light gray carpet selected. Select carpet color. Tan carpet selected. Select wall color. Light gray paint selected. Select wall color. Medium tan paint selected. Select flooring material. Concrete flooring selected. Select wall color. White paint selected. Select kitchen walnut wood flooring selected. Encounter material. Select wall cabinet color. Material. Walnut cabinet selected.
Hello, am I audible? Hello.
Yes, sir. Yes, sir.
Oh, sorry. I Yeah. So I was saying. So this is. I'll not go through the complete video because we have limited time, another 15 minutes available. So this is another very known and very recent area where walkthroughs are created using virtual reality. So you can actually create your own home before it is actually being constructed. So a lot of architects are using these walkthrough examples, and there are so many examples which are available on Play Store today that you can download it and then create your home environment, interiors, and so on, and experience the home before you actually build that home, before you actually create that interior space altogether. In addition to just the home, there are a lot of other walkthrough events that take place. Like you can have historical events in 1800 or maybe 1300. Similarly, you can have museums which you cannot really have direct access to. So if you want to access a museum in US or in Europe, you can sit over here and then experience the museum sitting and understand the contents of the museum. Similarly, any other walkthroughs that you want to create is something virtual reality has been extensively explored. And given that it has a 360-degree environment and immersed environment, the experience of these walkthroughs are almost real as if you're walking in a real environment. Yeah, so it basically some of the benefit includes it allows users to experience the projects or experience the houses firsthand instead of imagining the drawings and 3D worlds. It reviews the design prior to beginning of the construction, and especially in architectural walkthrough applications to find undesirable features the way the user was doing. You can do mix and match and find out which one suits better to your home. Enables to view design in different lighting and visual aesthetics, scale, accessibility, and usability of the space. And that's something very important in all kind of environment, not just home environment or a business or office environment, but even in museums environment or historical event environments. Yeah, and it allows creation of historical places, historical events, and museums to experience the event from the past. So that's another very known, very commonly found VR application area, that is walkthroughs. Yeah, and the fourth one is the data visualization. Now that's something that is not extremely common, but that's something that is picking up in last 3 or 4 years. A good number of research labs, a good number of companies are really exploring data visualization, especially when the data is massive. Like, for example, in case of COVID patient data or in case of election data. This is where they are using virtual reality because it has the ability to move into X, Y, and Z, especially Z axis, an ability to really be inside the environment and experience the data being inside that environment is something that really works in case of being in case where virtual reality is preferred than any other platform. So let me again show you one small video here.
Hi, my name is Will, and I work on something called Looker. Looker lets you access all of your data anywhere you need it. It is dope. Explore your data on the web or use our API to get data anywhere you need it. Alexa, how many units did we sell last week?
You sold 238 chocolate-covered honeybees last week.
Wow, sales are great. I can also use Looker to send data through Slack. We've been working on. Rather than blowing gazillions of VC dollars on relaxation pods or kombucha drones, we built a virtual reality lab. Far more practical. Let's get suited up. And now we're ready. Welcome to Look VR. So here I am in virtual reality. In VR, we don't have data tables, but we do have data tables. All the data here is powered by Looker's API. That means instead of having to source, load, transform, and massage this data in order to work with it, I can just start playing immediately. That means I can focus on the problem at hand, which in this case is visualizing data in virtual reality. A weird problem, but let's go with it. Why don't we take the silliest chart imaginable and make it even sillier? I'm talking about the word cloud. So here I am, standing in a cloud of names of people born in 2013, like you do. I can scale it down to make it a mere puff of smoke, and I can look at it down here. Or if I really want to experience the power of the cloud, I can make it enormous. And this isn't just a flat data set. Let's drill in and see the history of the name Riley. That appears here as a virtual reality scatter plot, which you'd think would be really stupid, but because all three of these axes feel physical, it's really easy for your brain to understand the relationships between them. So looking at people named Riley, we're plotting the birth year, the percentage of Rileys that are female, and how popular the name Riley is. The data shows that there are almost no female Rileys, and the name is declining in popularity all the way until the late 80s, when it suddenly becomes quite popular, and the vast majority of new Rileys become female. All right, wow, that was a lot of data. Let's, I'm thirsty.
Dispensing kombucha. Good day, sir.
Never mind. Let's check in on my business ventures. One thing people love to visualize is money. Here you can see all of my important business ventures. Clearly I'm doing quite well. These are all represented by stacks of $100 bills. For anyone who hasn't stood in front of $83 million in cash, this is exactly what it looks like. It's completely realistic. I know what you're thinking, but how does it big data? Let me show you. If we come down here, under the chart, we can find a button. And if I bop that button, the data gets really, really big. This data is so big that the only way to truly get a sense of its scale is to scale it. Let me grab these handholds here, and I'm scaling the data.
Yeah, again, I'll not go to the full video. He was just doing some gimmicks and all, but Again, one of the area is data visualization, where a good large chunk of data, especially data in lakhs and millions, is really been able to visualize in data visualization. Although this area is not um, as explored as walkthroughs and virtual training, but it's still an area that is coming out. The interactions are not yet very intuitive and effective. Even the graphical interfaces that are presented on these data visualizations are still in a bar graph format, which people are exploring in different kind of graphical visualizations, but still a very picking up area when it comes to virtual reality. Yeah, it basically allows useful analysis of the large data set. When you have space of interactive tools, you have effective visualizations, then it makes it a lot easier to build relationship between different axes. And it's easy to comprehend when you look at into X, Y, and Z, all the three axes. Yeah, it helps in the space of medical imaging when 3D data enables viewing from data perspective, especially when you are talking about CT and MRI scan data. The visualization of such data becomes much easier when it is in three axis as well as when it is explored in the virtual reality. Similarly, another kind of data visualization or scientific visualization which has been explored is looking at how the simulation of various things which we cannot really see with our naked eye, like flowing of air over the wing or blood through the artery, how atoms and molecules interact, and so on and so forth. So this is something that we can't really see with our naked eye, but it helps us simulate these scientific visualizations and experience these scientific visualization using virtual reality. Then there's something which I mentioned about experiencing the non-experienced. So this is again something where you put yourself into a different user's shoe and experience something. So this is an interesting project where a virtual reality platform application was created to let users experience how someone with some blind spots really see the world. So that's something that is very interesting, and similar other applications have come where you can experience how a blind user really sees the world. So it transports you into a world where basically you become a blind person, or you become a person who has blind spots into your eyes, and then it lets you see the real world. It lets you see the world, and then you lets you interact with the world. So you empathize with the user a lot. You understand the user a lot before you start, making any assumptions about the user. So that is what we call it as experiencing the non-experienced. Okay. And the other areas about the virtual reality for films, I have not covered it, and there is another area of virtual reality for therapy. So all of these areas are very extensively explored uh, commercially and research-wise, both, where virtual reality has shown great potential. There are a lot more other areas, in terms of medical, especially in terms of reducing the medicines and using the VR therapy to really reduce the burning sensations, reduce the fear sensations users have about hospitals. But that's something, it's purely in a research stage, and I'm largely covering something which has already established good results and which has commercial applications also. Okay. Now coming to set of advantages and challenges that we have in case of VR. There are very obvious set of advantages if you look at the application areas which I mentioned. So the first is it transcends the barrier of space and time. So you can build any applications in any area. You don't have to be at that physical space, or you don't have to be at that physical year. But I can just transport myself into anywhere in any time and experience any event that happens over that point of time. It lowers product development and modification time, because now you can create a prototype using virtual environment rather than building a physical product and realizing mistakes and redesigning and rebuilding the physical product. So it increases accuracy, reduces development time, modification time. And as it reduces these modification and development time, the overall cost is reduced. That is another major benefit when it comes to virtual reality. It increases, as in you have time saving, you have easy reachability of all the events that is happening across the world. Is something, another set of advantages that we have with respect to VR. Improved learning and skill set creation. So there is a saying that a picture represents 1,000 words. So you have a layer of learnings, which is first is words when you read something, the second is images, where images are better than words. And the third one is where you have experiences. So the more you experience a content, the better your learnability is. So now that is a third layer that is coming in, where educational paradigm or a training paradigm is not just about words and creating videos or visuals, but now experiencing them to learn more about it. So that is where the VR comes in, because it will lets you experience something before you actually get into the field. So your learning is a lot more, a lot higher as compared to just looking at a video or reading through the manual. So here you experience it and then go to the real world to apply your learning. Enhances engagement among the users, which again results into increased learnability and memorability. And that's another thing that people, whoever use VR, that increases the engagement and increases the immersion among the user as compared to any other traditional platforms like websites and mobile phones and so on. Yeah, enables imaginary visualization that is extracted from the real world. Like for example, you can now visualize what is stress, temperature, and other attributes which are generally not visualized. So it enables that kind of a visualization and helps you understand about the data, understand about the virtual environment a lot more than you would just imagine yourself and understand about that. Yeah, when it comes to different platforms like this cave like VR setup, it supports collaborative work immensely as compared to any other, even other VR platforms also, not just any other technology. But you can have 3 or 4 people coming together in a cave like environment, working together, modifying the designs, creating the designs, even physically coming together or virtually also coming together and working and creating better designs or better solutions to the problems that you are working on. So that is another major advantage of virtual reality, and especially when it comes to cave like environment that supports immensely collaborative work. Okay, when it comes to challenges, some of the challenges are very obvious, and some of the challenges are still challenges despite there's a lot of technological intervention, even commercially technological interventions have happened. Um, yes, now this is if you look at various virtual reality, especially HMD based devices, there is no standards of input interaction techniques or user interaction techniques. Now, if you use mobile phones, despite all companies have their own philosophy, you still have a 2D touchscreen devices, and touch is a modality where you start interacting with the device. Pinch in, pinch out, you do zoom in and zoom out, and some of these factors are very common. And it's been standardized across devices. Whereas if you look at the virtual reality platform, whether it's an Oculus or HTC or low cost virtual reality like Google Cardboard and so on, all of these platforms use different interaction techniques. Their remote controls, their controllers are different, their interactions in the controllers are different, their button sizes, button functionalities, everything is different. So then if a user shifts from one device to another, there is a learning curve that is associated with it. And that is one of the major challenge that current VR, HMD-based VR platforms are experiencing. All the devices are independent to each other. They don't talk to each other. There is no standardized input. There is no standardized input mechanism as well as standardized user interfaces. Like on mobile phones, you have radio buttons, check boxes, you have button sizes which are standardized. Whereas in terms of VR for graphical interface, there is no standardization. Every company uses their own method. Developers or designer uses their own method. So there is no guideline, no standardization to the user interactions as well as interaction techniques. Vection. Now, this is something what we call it as a vision and balance. Now, that is another challenge. Although VR is designed to have experiences as near to real world, it's still because of the limited tracking area, it is still not able to provide that real world experience. You will be able to experience to some steps or some feet, but still ahead the experiences are very limited. So that is another challenge where you provide better vection and a longer duration vection to the users. Then seamless integrations of real world experiences like head movement to picture movement ratio, head movement to audio movement ratio. Though image movement ratio is still better, audio movement ratio is still being into an exploratory stage. It's not as near as what you would do it in a real world environment. Immersion using other senses, something that we can really smell it or something we can taste it. Those senses are not really explored, which we really experience in a real world environment. So that is another thing which is missing out. Then degree of freedom. Though we have 6 degree of freedom, it is not as accurate as probably we can have it in a real world environment. And then field of view. Field of view is something which is probably in expensive VR headsets, you have it. But if you go for a low VR headset, you still have problems of field of view. It's not as it should be of 110-degree in a real environment. And because of this, it leads to a lot of discomfort and effect of nausea. And sometimes, if it is an extensive experience, then people start vomiting as well. Um, Latency, largely in case of the expensive headset, it is sorted now. I'm sure everyone knows what latency is. So it's all sorted in expensive devices, but when it comes to mobile-based VR, like low-cost VR, like Google Cardboard and all, the latency issue is still there. And because the expensive devices are not scalable because of the cost right now, a good amount of population use the low cost VR, and in the low cost VR, the latencies is something that exists, and that is that is resulting in a poor user experience of the applications we are using. Yeah, then there are certain challenges in form of physical safety, especially with HMDs. You are not, because you are completely isolated from physical world or a real world. You end up having safety concerns. You end up bumping into other people. You end up having bumping into physical objects that are surround you and all. So those kind of physical safety is one of the concerns. Some of the concerns with respect to psychological safety, especially in terms of collaborative VR or social VR space. I'll not get into that, but just to put up one sentence is the way you have Facebook. Now there are a lot of social VR spaces that has been created, like Alt Space, Facebook Social, into which you can create your own avatar and start interacting with people whom you don't know. Now there are a lot of issues related to harassment, related to psychological issues inside that virtual environment, because you are completely anonymous over there. Your face is not visible, so people start behaving very abruptly into these social VR spaces. That's a completely different topic. Probably next time, I can talk about it. But that is with respect to psychological safety when it comes to virtual reality environment. And yeah, the synchronization between different displays is one. And in case of multi-projection and cave, the discontinuation between the two neighboring screens, etc., is something really causing problems when it comes to virtual reality. Okay, I think I am almost on time. Yes, so I'm done with my presentation, and I'm now open to any questions or any comments from anyone.
Thank you, dear professor. Dear participants, now the platform is open for your questions and queries. Please interact with our eminent speaker. Yes, somebody is trying to ask. It's not audible. Otherwise, you can put your questions in chat box.
Sir, as it is discussed that whatever the devices that are present in the market, they don't follow the standard. They are a particular standard. So, is there any way to design a particular standard for them?
So see, it's a very new field, although it has started like a three decade back. But when it comes to the commercial devices, or even in terms of research, also almost in between the decade and a half, people just completely forgot about the VR. So it's relatively a very new platform. So that is why there is no standardization of the devices. There are few companies who are just producing these platforms, especially HMD VR, that is Facebook that produces Oculus, and HTC that produces HTC Vive. Sony produces PlayStation VR, and there is one more company which has seen some success. Because it is very less number of companies, there are no standardization. They use their own protocols, they use their own design guidelines to design their controllers, design interactions, and so on. So that is why complete lack of standardization is there. The way we have it, like we have Android guidelines or we have iOS guidelines, which are very well established for now. That's something that is not there in case of VR. Now, to come up with such kind of a guideline, probably that requires a lot more research. And a lot more platform dependency. Yeah, maybe one needs to do a PhD in one specific area and then propose guidelines. But currently, as in, it's just purely onto a research stage where some graphical interfaces or some interactions are explode in all the platforms. Like now, HTC and Oculus both come up with the cameras that can track your hand, and not just your hand but fingers. So now what they are proposing is that if you don't have controllers, what Facebook or HTC provides, then you can use your finger gestures without having any kind of controllers to start interacting with the application. Now that is a one step ahead in terms of making a standardized set of gestures or standardized set of modalities to interact with application. But that's again, Facebook does not really recommend a very strong set of gestures, or HTC does not recommend. So what researchers like myself in my lab or a lot of other people across other universities abroad, what they are trying to do it is come up with some gestures or a combination of gestures and speech to propose some kind of interaction modality, like how do you open an application, or how do you rotate a physical object, a virtual object, or how do you throw a virtual object from one location to another, and so on and so forth. So that exploration is taking place, but there is no current commercial standard guideline available. That's all still in the research stage right now.
Okay, thank you, sir.
What would be the impact of VR on societal behavior, sir? Already, our children have changed their attitude because of online platforms, online classes. They have been isolated from classroom environment. So, in that aspect, what would be the impact of this VR on the attitude of children or societal behavior?
So that's something that is a very debatable part. There are two sides to it. One is the good side where the VR provides engagement to the learning. So nowadays, Baiju and a lot of other companies just yeah, sorry. So good side is where you have these platforms that can create engagement among the users, increases learnability, and because you start experiencing, say, electron, proton, neutrons, or experiencing all the contents that students learn through a book. That is where the learnability increase, and which is what the good side of it. Now the bad side of it is, which I told you about, the social VR space, where because you are anonymous, you don't have a face. If you have ever used a virtual reality platform, you actually don't have your face, but you create your own virtual avatar, a 3D avatar of yourself. So you just have a cartoonish face. You can put, your you can put some specs or hairs, etc. So you create basically your avatar. Now, because that is an anonymous, nobody can see you, nobody can have your name also. People have very weird behaviors and fantasies experienced in these spaces. Now, that's something that is currently into ethical consideration of how do we design such social VR spaces. Like there are so many good research papers and which have studied like 100 hours or 200 hours of behavior of different people into these spaces. The bullying starts happening over there, the racial comments start happening over there, the sexual comments start happening over there. so many things are happening which are not in a very good shape. So although it's still in a research stage, although it is showing the dark side of a VR of how people really behave when you are anonymous and nobody knows you, how they gang up with people of similar nature and how they really bully other people and so on. So that is something that is into place where even the companies are forming certain ethical guidelines. That you a very simple guideline I can tell you now it has come where in even in a virtual space when you create your own avatar, the other avatar cannot come near to you, very near to you as you would not allow anyone to come in a real environment. So that is one thing that everyone has started. That if there are three people standing in a virtual environment, you can't just go and bump into someone's face or bump into someone's body. So those because people that is what the behaviors were, what people were doing in a virtual world. These now new guidelines are coming up, especially in ethical guidelines are coming up. But yeah, as any technology platform, you have a positive side and a negative side. Largely, currently, that is, given that the exploration of VR is limited in Indian context specifically, it is more towards a good side because people are purely exploring in two domains, which is education and healthcare. There are some universities who are trying to teach surgical training to the doctor students, using virtual reality. And same way in education space, also people like My Lab or there are companies like Byju's also trying in virtual reality and seeing how education can be improved. But social VR and all is something that has not been explored in Indian context. It is very, very extensively explored in Western context, especially in US. So, but hopefully that will also come in India maybe in a few years. But as it is, that there is a positive and negative side both.
Thank you, sir. Thank you for your elaborate answer, sir.
I hope I followed the time, right? As in, we are not over timing or we are not, because I was told that we have 45 minutes.
Yes, sir. Okay. Timing is okay. And any more questions, please? Or we can. Sir, whether your lab will accept the students intern in this domain?
Yes, my lab has student interns, and I am also looking for good PhD students who want to join the lab. But yeah, we do have student interns. Even right now, also, we have a full VR lab, complete setup with all the advanced headsets and everything available. So yeah, so if you have some good students, we would be more than happy to have them in the lab.
Sure,
Although
sir.
it's going to be online for some time, but hopefully everything starts physically. But yeah.
Sir, really, it's amazing that sir, new topic. That's what much more questions are not interaction. The participants are not interacting. It's surely it's an eye opener for them as well as myself. Really nice talk and nice lecture. If possible, please share the content what you have presented here to share the participants.
I will send it via email. Yeah,
Yes, sir. Yes, sir. Thank you, sir. Thanks a lot. And once again, we thank on behalf of the organizing team and Vimal Jyoti Engineering College. I thank you that your wonderful lecture and the interaction with the participants. And you spare your valuable time with us. Thanks a lot.
Thank you. It was an honor for me.
Yes, sir. Thank you.
Thank you.
Thank you.
Thank you.
Thanks a lot. Bye. And dear participants, our next session, as per our schedule, we will start after lunch. So please join 1:15 positively. Okay, so it's a 1 hour break. So join back 1:15. The resource person is the senior scientist TCS Research, Dr. Brajeswar. Brajeswar is delivering his lecture in the afternoon session. So please join in time, and we will meet back at 1:15. Thank you all.